Okay, as a practice with some solution concentration problem. Uh, let's see, we have this question. What is the molarity of let's say 20 gram NaCl in 200 milliliter 200 milliliter water. Molarity equal mole divided by volume solution, mole solute, divided by volume solution, but the liter unit. Now, the volume we have is 200 milliliter. To convert it to liter, it will be 0.2 liter. So put here 0.2 liter. What about the mole? We have 20 gram for the NaCl for solute. So here, mole NaCl will be mass NaCl divided by molar mass NaCl. So here it will be 20 gram NaCl times 1 mole to the top and 58.5 NaCl, which is the molar mass. Now do the math. So we will have 20 divided by 58.5, and you will get 0.34. So here will be 0.34 mole NaCl. Now this 0.34 mole NaCl will be divided by the 0.2. We will get here 1.7 mole per liter. Or you can say 1.7 capital M, which is mean molar. This is molar. It's called molar. Okay. Let's go and practice with another example. Okay, now let's see which example we have. Okay, let's say how many grams of say NaNO3 we need to prepare 500 milliliter of 0.1 molar solution. Okay, so here, how many grams of NaNO3 we need to prepare 500 milliliter of 0.1 molar. Okay, now we know that's the mass. We can calculate it from this relationship here, mole equal mass divided by molar mass. So if you have the mole, you will multiply it by the molar mass, and you will get the mass. So here mass equal mole times molar mass. But here we don't have the mole. We don't have it. But also we have this relationship between molarity and the volume. So here, molarity, capital M, equal mole divided by volume in liter. Here, mole will equal molarity times the volume in liter. So we will use these relationship to calculate the mass. So first of all, we need to figure out the mole. So mole here equal the molarity times the volume in liter, and the molarity 0.1 mole divided by liter. Here, when they told you 0.1 molar, that's mean 0.1 mole divided by liter. The molar, it is mole divided by liter. Okay, times the volume in liter, they give it to you 500 milliliter, so it will be 0.5 liter. So it will be 0.5 liter, cancel liter with liter. 0.1 times 0.5, so it will be 0.05. The next step, we will calculate the mass, m, equal to what? The mole, 0.05 mole, times the molar mass. Which one you will put it in the top? It will be the mass. So here, what do we have? 23 plus nitrogen 14 plus 3 times 16 for the oxygen, so it will be 48 here. And excuse me. So here 58, 62, and 85. Just check the number, guys, after me. So I think it will be 85 here. Yeah, 85. Sorry, we will put it in the top. 85 gram. The gram will be in the top, and 1 mole will be about 1 mole. Cancel this mole with the small, and we will get here. I think it will be 1.7. 7. Let's just double check it. 0.05 times 85. Sorry, it will be 4.25. 4.25 gram. And that's how much we need to prepare 1 molar solution. Not 1 molar, sorry, 0.1 molar of NaNO3 solution. Okay, let's practice with other example. Now for the dilution practice. So let's say we have, okay, how many milliliter, we need from 0.1 molar H2SO4 to prepare 0.005 molar to prepare 500 milliliter, 500, let's put it in 500 milliliter, 0.005 molar H2SO4. We know that M1V1 equal M2V2. The M1 here, 0.1. It is the stock solution, the large concentration. Or it doesn't matter, by the way. It will be the same calculation. You will do the M1 0.1 or M2 do it 0.1. It doesn't matter. But M1 usually is the stock solution, the larger concentration. M1 0.1 molar times the V1. They are asking about it. The M2, it is 0.005 molar times the V2, 500 milliliter. By the way, here in the dilution equation, volume is not necessary to be liter. You can leave it with a milliliter, but it's up to you. You can convert it to liter. There is no problem. Okay, now V1 is unknown. So V1 will equal 0.005 molar times 500 milliliter divided by 0.1 molar. Guys, here it's supposed to be in milliliter, sorry. Why? Because they ask you in milliliter, but if they didn't ask you, it's up to you. Keep it in milliliter or convert it to liter. Cancel molarity, the molarity. Do the math here. So it will be 0.005 times 500 divided by 0.005 times 500. Then gives you 25. So we need the 25 milliliter of the stock solution 0.1 molar H2SO4 to prepare 500 or 0.005 molar. Okay, let's look for the solution stoichiometry example. Okay, for solution stoichiometry. Let's see, what do we have? Okay, let's say we have HCl solution plus NaOH solution. We will get HCl plus H2O. This is the solution. This is the okay. Now let's look at this example. First of all, how many milliliter of of 0.1 molar HCl we need to produce to produce, let's say, for example, 200 gram NaCl. How many milliliter of 0.1 molar HCl we need to use to produce 200 gram NaCl? Now, look at here, what they give you. 200 gram NaCl. Guys, here they are asking for a volume, milliliter, okay? We have the molarity. What we need to calculate the volume? We already know molarity equal moles divided by volume. And don't forget also the second relation Mole equal mass divided by molar mass. So here volume, to calculate it, we need the mole and molarity. We don't have the mole of HCl, but we have mass of NaCl. Now, don't forget the mole to mole ratio between two chemicals, X and Y. So first of all, we will convert the mass of NaCl to mole. So here, times 1 mole divided by molar mass, which is 58.5 a gram NaCl. To cancel this one with this one. Now we get the mole of NaCl. Now we need the mole of HCl, so we will use the mole to mole ratio. What is the mole to mole ratio? NaCl, HCl, it is 1 to 1. So it will be 1 mole HCl divided by 1 mole NaCl. Cancel mole NaCl with mole NaCl. We have right now the mole of HCl. Now they are asking for the volume. Volume equal mole divided by the molarity. So here the mole in the numerator, so just time 1 divided by molarity, which is 0.1. 0.1 molar, which is mole divided by liter. Do the math right now. So we have 200 divided by 58.5. Now divided by 0.1, and we will have 34.2. So here will be 34.2 milliliter HCl. Now for the same reaction, let's say we have this equation. Let's say we have, or they are asking, okay, calculate the volume of NaOH of 0.2 molar NaOH that required, that is required to neutralize 500 milliliter of 0.05 HCl. By the way, this is considered stoichiometry and the titration also, because the titration is also one type of the stoichiometric calculation. So here we will calculate how much the volume of 0.2 molar NaOH required to neutralize 500 milliliter of 0.05 HCl. Now, again, to calculate the volume equal mole divided by molarity. Here we don't have the mole, we don't have the mole of NaOH. I'm just talking about NaOH. So we need the mole of NaOH. How we will get the mole of NaOH? We have volume and molarity of HCl. Mole equal molarity times the volume. Mole equal molarity times the volume, liter. We will get the mole. But this mole will be for HCl. Then we will use the mole to mole ratio to calculate the NaOH. So here it will be 0.5 liter times the molarity, which is okay, this is molar, guys. 0.05 mole divided by liter. This is HCl. Cancel liter with liter. Now we will use the mole to mole ratio, which is 1 mole NaOH divided by 1 mole HCl. Some mole HCl with this one. Now I have the mole times 1 divided by molarity. I give you the molarity 0.2 molar. And here it will give you the volume in liter. So here it will be 0.5 times 0.05 times 1 divided by 0.2, 0.125 liter. And this is the answer for the question, which is approximately will be 125 milliliter if you want it in milliliter.